Okay, now we're going to look at some real data and see how we can use parallel axes to investigate the structure in real data. We look at the olive oil data, which we know has a bunch of different areas associated with the growing regions of the particular olive oils, and the eight-dimensional measurements are the measurements of various fatty acids. Um, for parallel coordinate plots particularly, it's really important that you have an interactive display, and so we're going to use Loon's L underscore serial axes with the axes layout being parallel, and that will look like this. And so when we look at this data set, where I've added the labels, so I've turned on the show axes labels, although they're false in the slide there, so that we can see the labels themselves. And you'll notice that there are bunches of groups here. I have a line here that I can move around, sweep out in this parallel axis plot. When it intersects one of the curves, it highlights it. So if I highlight different pieces of it, I get to see different curves, groups of points across the whole space. So you notice there are concentrations of curves here and there and spaces between them. And we're looking for that, where there are concentrations of curves, and also where, we know when curves crisscross that it's kind of a negative correlation here between these two variates, and when they all join together, they're falling on a line, etc. And perhaps if going across all of these axes, the particular ordering we have, we see that this last axis here, there seem to be two large groups. There's this group, which again separates in a bunch of different things, and then there's this group, which may also separate in these different ways. So what I'm going to do is take one of these, just take that and cut them away. So I'm just focusing on this last group. And that last group seems to have some structure where the points seem to separate. Like there's a nice defined group. So I think I'm just going to give that a color, commit to that, and take that away and see what have I got left. Now I have a nice group here, which also looks pretty good. Give that another color, cut that away, and now I have this. Now, is that all one group, or is that two groups or more? I'm not so sure. Let's look at these ones here that seem to crisscross there. Is that different from this group here? They seem to have a tight configuration here. I think I might separate these two as well. So let's call that a group and cut it away. Again, this is very quick and dirty. So this, wow, that guy's a real oddball. Let's give him some strange color. So I'll add a new color here. We'll give him this, I don't know, bright yellow color. And I'm going to just cut that one away. So this is one group remains. It's probably enough to drop it down to that without committing to that yellow guy. And we need another color here, so let's have the greens. And bring everybody back. Oh, I guess I didn't get that. I think that, yeah, that was the yellow guy there, so we'll make that one yellow. And the black are the ones that we haven't yet dealt with. So I'm going to invert that and deactivate everything else. So now I want to tear this apart. And boy, that looks a little more complicated. It looks like one giant group here, actually. So maybe these guys are a bit different. Certainly those ones. That's a little much. Let's call that something. A bit of injustice here, no doubt. Green. Okay, let's that purple one. Cut that away. And then it's a question of, I'm going to break that out down into a group. Yeah, maybe. As distinct from the black ones. So let's deal with that. So that was the purple. That's that green. Deactivate it. And just in the interest of time, let's just not deal with this one anymore, although there are clearly some funny points like that one. It's an oddball, and then these guys maybe. But let's just call that all another group. And I've got, what was the last one I had here? I don't think I have this one. Right. Color that anyway. So, and reactivate everybody. So there's a grouping. So how good is that grouping? Well, we might check how good that is grouping is by seeing how well did we get the actual areas. Here are the areas of the olive oils, the regions they're grown in. And so we can identify any one of these by seeing where they are. And so I could see the different regions and what they look like in the parallel coordinate plot. And sure enough, they look like they have some structure. Wow, that one's a bit messy. That one's a big fat one. And we can see how well we did by just looking at these things with these stacked colors. So, oh boy, that's not too bad. Now this green one, we got most of that one right. This blue one we got entirely correctly. This one we got right. This pink one, oh, is that the last one? No, that's two different pinks. Okay, so those are two different groups we have, are they? No, that's not right. I think that's the last group, is it, that we looked at? Let me just invert and get everybody else away. I can't remember whether that was the last one we decided to separate or not. Anyway, not too bad. Some bleeding over between groups, so that one got fairly well separated. This dark green one got fairly well separated. That blue one did. This purple one not so much. Got contaminated across these groups. That green one very well separated, and these ones a little hard to put out. That brownish one. So, just with looking at parallel coordinate plots alone, we're able to kind of, at least very quickly, identify some unusual groups. There's the odd duck, that yellow one. So there you have it.